we present IGNOR, an image-guided neural object rendering approach. Given a video sequence of an object, we use multi-view stereo to reconstruct its geometry. The reconstructed per-vertex color is not sufficient for re-rendering the object. The goal of our approach is to synthesize an image as shown here on the left, the target sequence. A naive image-based rendering approach using frames from the recorded sequence leads to flickering artifacts. In contrast, our approach generates a realistic-looking image with temporally smooth view-dependent effects with the same input as the IBR method. We propose EffectsNet, an encoder-decoder network that estimates the view-dependent effects of an object given a depth map and the current rigid pose of the object. Using this predicted effects layer, we can generate a diffuse image of the object by subtracting it from the original color image. This network is a core component of our approach, since we can directly incorporate knowledge about view-dependent effects into the composition of new views. Without this prediction network, the composition results in non-smooth specular highlights. Based on the target depth rendering of the reconstructed geometry and the target rigid pose, we select 4 frames from a subset of the recorded video. For these so-called reference views, we predict the view-dependent effects. We remove these effects from the color images, resulting in diffuse images that can be reprojected into the target image space. In the target image space, we add new predicted view-dependent effects. These images are used as input to our composition net that outputs our final image. Here we show some results based on synthetic input sequences. We first show a side-by-side comparison to a naive image-based rendering approach that is based on the same 4 images as our approach. Here we show a comparison to the image-to-image translation network Pix2Pix that receives the depth map as input. Here we show results on real sequences. Our approach is less sensitive to a lower number of images in the training corpus than Pix2Pix. Reducing the number of frames leads to low visual artifacts on our approach, while Pix2Pix drastically degenerates. Thank you for watching.